Hi, I'm Bert, and I'm also known as Piscasaurus. What I want to talk about actually is, usually what I would do is talk about Libuv, because that was my major thing I worked on the past couple of years. Libuv actually got some rad changes, like we made error handling better, and like we returned an error code instead of just -1, for example. And what else did we do? Oh, we did do something groundbreaking, which is now C-time. If you stat a file, C-time means the same on every platform. Like, this is unique. This has not been done in 30 years. If you're like, what's this all about? Fine. I mean, it's very specific. I'm going to talk about something maybe more abstract today, and something that maybe concerns a little bit more people. First of all, this talk has two parts. Like, the first part is actually quite abstract, but please try to follow me along, because it sort of explains where I come from, and then the second part is easier to understand. So TJ, he was complaining in his opening talk that I didn't do exec-sync. Instead, what I did when I should have done exec-sync is like read websites. I don't know, Hacker News. You guys do it all the time as well. And the Node mailing list, also a great time sync. And then there's like a Dutch website called nu.nl. It's news. You can spend an entire day there and procrastinate everything that's really important. And so what was really noticeable last summer is last summer, that's like very northern hemisphere centric, of course. Sorry, Australians, you are left out here. But it seemed to be the Node summer of bike shedding, right? Like, people would make posts like this: future of asynchronous programming in Node, because obviously this was the right time to turn it all upside down. And also this one: future of Node streams, we need to talk. And then I think Miguel de Icaza, he's quite known for building Mono. He did this post, and I actually thought this was good. Callbacks as our generation's go-to statement. It's weird that he put a space between go and to, but details. But like, what it really did is get me thinking about Node 2. And the other reason is, of course, that Isaac really got upset with all this, and he said, there will be no Node 2, like Node 1 is done, and it's released January 1st. No, I mean, I like my job. I'd rather not have it done January 1st, right? So let's go think about Node 2 a little bit. Now, next slide, yeah. Here's a couple of common causes of bugs in Node applications. I witnessed this over and over again. It was very painful when I was working at Cloud9. But like, where people, like actually smart people, were trying to build a very complex and big a Node application. And fixing bugs in Cloud9 was like whack-a-mole. You would like fix one place where you didn't handle an error correctly, and then another one would pop up, because you would run right one more step, and then you would run into another issue that had the same problem, or another place where you did the same thing wrong. And there's a couple of these, like double and missed callbacks, and people do ad hoc ironing out of like flow control problems. I never wrote an implementation of a semaphore, for example, before I started to do Node, and now you have to do it all the time, because you want to wait for two things and then call one callback when both is done, but you don't know in which order they're going to be completed, so you have to count how many callbacks you get, for example. Not handling errors, Renos talked about that. I'm going to talk about it way more, and well, maybe more vague maybe. You have to use nextstick. I mean, nextstick is really, like, it's annoying, right? Now you're supposed to not call a callback synchronously, because you read Isaac's blog post a long time ago, and he says you shouldn't do it, so you listen to the big leader. And now you have to put nextstick everywhere. It's very, why? What's the point of that? So, I didn't want to go there. So, like, for an example, this is what people do, implement a semaphore on their own. And this one is interesting. So try to do curl in Node, and we have pipe, right? It should be easy with pipe. I had to do this actually when I was teaching another girl, woman at Cloud9, how to do it in Node, and she had a PhD in computer science. I'm not lying, but she didn't know JavaScript or Node. And then it turns out it's easy to download a file or to curl a file with Node, but then if it goes wrong and you don't want to crash, you have a problem. You have to do all this crap like, oh wait, the file fails somehow, then I'm gonna destroy the socket, and if the socket has an error, destroy the file, and if both fail, then, well, you don't want to, call the final callback twice and all that terrible shit. This is a problem for us. So, and now, yeah, and so back to this statement. I actually agree with it, and I don't want to do the Hacker News discussion over again, and probably nobody agrees with anyone. But the thing is, with callbacks, they're similar in a way that they express really what is happening in your, to a certain level of abstraction, but what's happening in your VM. A go-to statement is basically just a jump. Your processor continues run code somewhere else. A callback is basically, we had some code that we wanted to run at some point in response to something, and then we're gonna do it, or maybe not into response to something, do it. But it doesn't encapsulate any intent. It doesn't encapsulate, it doesn't tell Node anything about why you are using a callback there. In Node, of course, we also have event emitters. They do encapsulate maybe some intent, but here's something for you to chew on while I babble on. What does it mean? What is the meaning of an event emitter? If you say, well, a for loop is you take a number of steps. A while loop is you do something as long as a certain condition is true. What does it mean to have an event emitter? Anyway, so this was the abstract part. I want to add something to Node, and it looks like this. Oh, wait. Let's skip. Let's do the design criteria first. I want to add something to Node, and it should be a construct for working with callbacks, and it should capture more intent, and it should make it easier to handle errors, and it should make it easier to. You should not have to worry about next ticking stuff, and it should help you to build robust applications that don't crash all the time. And of course, we've had promises and stuff, and there's been endless debates about it. But one of the problems is, they were actually ripped out of Node because they were bike-shedding territory. People could never agree on how they worked or how they should work, and everybody had their own, wanted their own sugar pill added to the mix. And so eventually the decision was made, just rip it out and go back to the go-to statement of our generation. But now we have to find something again. And of course, because Node, we've seen how many we might be growing with 100% a year, but we already have a shitload of modules, and we don't want to break them all, and we don't want to break your app, or I'm saying we, but I don't want to break your app, and the other core team members don't want this to happen at all so far. But I do want to have it in core, or to some extent in core. It's not possible in user land in a reasonable way, and I think a construct like this is in a platform that is asynchronous by nature. You need a high-level construct for working with callbacks. So this is sort of the general idea I would want to have. It's very obvious. That was the intent. It would be like an asynchronous try-catch block. So you could do stuff in the try phase, and you could have callbacks there, whatever. But only if all the callbacks were all the asynchronous operations were completed, and all the event emitters were gone. For example, we would eventually call your finally handler, and it actually looks very much like a normal callback right now. So it has error first, and maybe results as later arguments, and that would run afterwards, and it would express intent, like you were trying to do a couple of things, and then do something with the result, deal with the result. Of course, we cannot change the language, so this wouldn't work, but we can do this. Have a function, and you pass it a closure. It generates basically a task object. I'm calling it task because I realized later that's actually very similar to what you have in C# as a task object. And then when you have that object, you can say set callback, for example, and pass the callback. That's how you could do a finally block. You could do like promises do, like .then, and only get it called when the operation succeeds. And the nice thing about this, and that's much better than promises, is that you can actually compose them, because if you create a task within a task, it just becomes part of the outer try-catch block. And if you also would do a set timeout, then both would have to complete before your callback gets called. And, well, as you can see, you get the error first. So if anything goes wrong in that box, we will pass you the error, and we will guarantee that your callback always gets called once, exactly once, never more, never less. So, like, think about a very nice API in Node. Well, nice, I mean, people say you need streams, but really, like, nothing is simpler than doing fs.read file with a callback. You pass it a file, and you know what's going to happen. Your callback is going to get called in the end, and if it didn't work, it's still going to get called. Now, if you look at actually how fs.read file is implemented in core, you'll see the problem that you deal with on a daily basis, which is, well, read file is actually implemented as with primitives, with more primitive operations. And now we have to do stuff like, well, if a read operation failed, then we must not forget to close the file descriptor, and after that call the user's callback. And of course, if we fail to close, then, well, then what? We probably want to pass the first error to the user and not the second one. All the stuff that's really like, we wouldn't want to think about it, and you should definitely not have to do that. So if you could actually implement this function with task in a quite trivial way. Well, let me see if I have my mouse here. So basically, the trick would be you wrap it in a block that says like create a task and pass the callback that the user specified to set callback. You could do that. And then in here, do error handling the way Jake told you not to do it. Just throw whatever, and Node would figure out what to do with it, because it's all wrapped in a task container. So this almost sounds too good to be true, and but we have one problem. So the problem is the event emitter. I use this image, by the way. I did a talk last year at Alex.js, and it was recorded and put on YouTube and actually got like way more views than we expected. And then we realized, or I didn't actually, someone from Alex.js did, the blur picture, the screenshot that you see in the list was this picture. I think many people just watched my talk, or at least clicked on it, because there was some dude doing something extremely gross. Well, I mean, it's for the good cause, right? Well, in this case, you could make, if you created a task within there, well, in the task, an event emitter, and add a listener there, it would be all fine. It would work as you would expect. The problem is, if you create a task and you start interacting with an event emitter, that was already there. I mean, you do that a lot in Node. Well, for example, you use process.on something, process.on message if you use cluster, or you would use if you did something more fancy like a database connection pool, you would have a set of connections, and then as you would start to query, you would pick one of these connections and start interacting with it. So we have a problem here. So what we're going to do, or what I would want to do, is all the event emitters that Node has internally, we're going to replace that by something called a resource, which is very similar to an event emitter, but with slight modifications. It works like this. If you add an event listener to a resource, you become vulnerable. That means if the resource goes down, your task will fail, and the error will be handled, it will be sent to your callback, etc. You can have an error handler in there. So that would look like this. You're interacting with a connection that's not created as part of your task, and well, you can have an error handler that could do anything. If you wouldn't specify it, you would actually get this. Like, the default behavior would be to throw inside of your task. Very simple. There's some more rules. They're not really that interesting. We can discuss that offline or something. Listeners have sort of an end, and that is when the resource is also ended or closed. You cannot call .emit on something, like something implicitly generates events. You cannot do like, process.standardin.emit key press. There's modules that do that. Bad idea. Like, I mean, you can use them, but don't write them, please. And then finally, there's sort of a treat. And the treat is this. It's very hard to see. I wonder if I can make this a little brighter. So, well, this is actually more or less a Gantt chart. Yeah, that's better. This is more or less a Gantt chart. I'm not very good at charting either. Like, suppose this is the first tick of your program, and then we do a set timeout, and eventually we'll get a callback there. And at the same time, when your program starts, we start listening on the socket, and eventually we will accept the connection. And, well, when you accept the connection, that's what happens under the hood. We will accept another connection, and when it actually comes in, we will get a callback. And so, like, think of your Node program walking or running like this. Or for example, here we do a read. It takes a while, but then eventually the data comes in, and then as a response to the read, we do a write, and we call also shutdown, which is like the equivalent of stream.end, but like more low level. And I mean, this, if you could look at your Node program like this, it would be obvious how it worked. The only problem is Node doesn't track all this, and it can't, because this at some point becomes infinitely big. If you run it for a day, it will be so big you would overflow your memory. So what Node actually sees now, for example, if an error would happen in a response to this read, it would fail in the callback. What would it know? Well, what it would know is, well, we were just starting a write, and there's some read pending there, and there's a set timeout pending there. Like, it cannot look into the future, and it cannot look into the past. So that's a problem, because that's why stack traces are really useless in Node. But if we do tasks, at least we can do a little bit better. So like this, it slides, but in fact it's the same image. It's just there's like a sort of a box, an overlaid box. And this could, for example, be a task that you wrapped around, well, accepting stuff, and then reading the request, and then writing the response. If you wrap a task around it, Node suddenly knows that, hey, you were handling a connection. You could give it a name, for example. Hey, you were handling a connection. And now, even nicer, suppose that like the reading part was wrapped in another task, because you can wrap a nest task. Now what we get is sort of a nice stack trace, basically, where we say, well, we were reading, and it was part of, well, like a big plan of reading stuff from a socket, which was part of a big plan of handling a client connection. And we can actually name stuff, because if you look at the task API, what we could simply do is give these functions a name. And then, well, V8 has the function.name property. We could look at that and print it out. So a stack trace, what it would look like, is more like this. And it's still not super useful, but it's a lot better, in my opinion, especially when you use external libraries, where we could say, well, error, it was part of like the inner task, or like the handle client blah task, which was part of, well, a bigger plan, and underneath that could be another bigger plan. And so the stack trace would not really tell you the complete history of a callback, but it would tell you what you were trying to achieve. So all this, I've been working on it for a while, like on and off, reading Hacker News most of the time, so it's not working yet. Unfortunately, but here's the code. If you want to look at the at this presentation again, I would recommend it. Look at it again. It's so nice. It's also in this GitHub repo. I called it new.js because new was, well, it's like the website that I read all day. And also because it sounds like new and it wasn't taken. It's also a big concern always. This afternoon I will try to do a bike shedding workshop. So please come and like tell me how I'm completely wrong, or that the callback should have like the error last, for example. I don't know, would be nice, right? Or other great ideas. I will also answer any questions, because I've really only scratched the surface. There's a lot more specification to it already, and you want to know about it. And I don't know, there's no room for me booked, I suppose, but if you can't find me, I will probably be in a non-obvious location. I will tweet it, so you can find me anyway. All right, thank you very much.